Hello again, my fellow geeks, and in the last video we discussed the properties of the determinant, and I left you with the homework assignment of finding the determinant for this quite a large, I'd say, matrix D. It's 4 by 4. So if you try to really just use, for example, the first row, or the, say, I think the second column would be the easiest way here right off the bat, and it would still look pretty complicated. You'd have to break it apart into 3 by 3 matrices that you would then have to calculate. And I just say that's not a smart way to work, not a smart way to do things. Instead we're going to look at what we can do with the matrix to simplify the order of the determinant and make the calculations much simpler. So I'd start by following our classical rule of taking the column or a row that has the smallest numbers and the most zeros. So that's, as you can see, the last column in our case, and we have this nice number 1 at the top that we're going to use to modify the rest of the numbers in the column. And we start by multiplying the first row by -1, and then we add the first row to the third row, thus changing the third row. So let's calculate that and see what we get. Our new determinant is 3, -2, 1, 1, 5, 1, 2, 0. The last row is 2, -1, 6, -3, and the third row that we just modified is going to be -4, -3, -2, and 0. So now we're looking much better. We have 2 zeros, and next we will get rid of that -3 at the bottom of the last column. So it's the same procedure. We use our first row, and we multiply that by 3, and we add it to the last row. So that will be 9 plus 2, or 11. -6 plus -1 is -7. 3 plus 6 is 9. And 3 plus -3 is 0. So there you have it. We have effectively ordered the order of our determinant. And what we will do now is we will use the last column to calculate the remaining determinant, and there's more. We will simplify it even further, as you will see in just a second. So let's write it as 1 times the third order determinant, that is the remaining 3 by 3 matrix, -4, 3, -2, 11, -7, and 9. There you go. And one thing, important thing to keep in mind, is that this last term in the first row is actually negative. Remember the symbol matrix, the chessboard with pluses and minuses? So that is actually -1. In this case, we have this number 1 in the second column, and I think we'll use that to calculate the the determinant. So first, let's start by remembering one of the properties of the determinant, that we can actually put a factor into one of the rows, and we have this -1, which can be conveniently placed into the second row of our 3x3 matrix. And writing it down, we will have 5, 1, 2, 4, -3, 2, 11, -7, and 9. Now, what we're going to do is we will multiply the first row by 3, and we will add that to the second row. And that will give us, the first row is the same, and the second row is going to be 15 plus 4, or so, 19, 0, and 6 plus 2, 8. And the third row for now remains the same, but now we will multiply the first row by 7 and add that to our third row. So that equals to, again, 5, 1, 2, 19, 0, 8, and 5 times 7 is 35, 35 plus 11 is 46. So we have 46. Here it's going to be 7 minus 7, it's 0. And lastly, we have 14 plus 9 is 23. Looks much better, doesn't it? We will now use simplified even further using our second column. And another thing, again, is that the second term of the first row is actually negative. So we will write it as -1 times a simple 2x2 matrix of 19, 8, 46, and 23. So if you calculate that, this essentially equals to -1 times 437 minus 368, which gives you -69. There you go. Now, you have to admit, this is much, much simpler than if you just decided to use the second column in the original matrix without simplifying anything. Just like that, with a few manipulations, you have your final answer. There you go.
Now that you understand the basics, we can cover even more advanced topics. Like this video, and let's move on to the next one.